Good morning, friends. First of all, I'm going to introduce myself. My name is Muhammad Ashik M. I'm from Kerala University, student of MSc Computer Science. Here, I'm going to introduce and to say about random algorithm. You know about random algorithm. It is a mathematical expression in the computer operating. An algorithm that uses random number of decisions what to do next anywhere in the logic is called random algorithm. For example, in the randomized quicksort, we use random number to pick the number pivot, or we random shuffle the array. Typically, this randomness is used to reduce the time complexity of the space complexity in other standard algorithms. Some randomized algorithms have deterministic time complexities. For example, the implementation of Karp's algorithm has time complexity is O of E. Such algorithms are called Monte Carlo algorithm and they are easy to analyze for worst case. On the other hand, time complexity of other randomized algorithm is depend on the value of random variables. Such randomized algorithms are called Las Vegas algorithm. These algorithms are typically analyzed for expected worst case. To compute expected time taken in worst case, all possibility values of used random variables need to consider in worst case and time taken by every possible values need to be evaluated. Average of all evaluate time in expected worst case time complexity below fact are generally help in analyze all such algorithms. Here I show some example of randomized algorithm. The center pivot is a pivot that divided into array in such a way that one side has at least 4 1/4 elements. If the worst condition, if low less than greater than or equal to high, then exists. While pivot X is not a central pivot. There are 4 conditions are here. Chosen uniform at random a number from low to high. That's the randomized picked number Bx. Count element in array low to high that are the smaller than array X. Let's that count to be second. The count element is in array low to high that are greater than array X. Let's this count to be GC. The last condition is let n is equal to high minus low plus 1. If S greater than or equal to n by 4 and GC greater than or equal to n by 4, then X is a central pivot. The partition array around the pivot X. Here I am going to say about the randomized algorithms mathematical background. Consider the probability condition P A by A. Insert the probability of event A happen given that then event B happen. P of A by B is equal to fraction of P of A by B P of B. We can easily understand about the formula using below diagram. Since B has already happened, the sample space reduced to B. So the probability of A happen become P of intersection B divided by P of B. Below the base formula of condition probability. P of A by B is equal to fraction of P of B by A into P of A into P of B. Then the formula provides relationship between P of A by B and P of B by A. It is mainly derived from the conditional probability formula discussed in the previous post. Consider the below formula for the conditional probability P of A by B and P of B by A. P of A by B is equal to fraction of P of A cap B into P of B is equal to the first condition. P of B by A is equal to fraction of P of B by cap A, the P into P of A is a second condition. Since the P intersection A is equal to P of A intersection B, we can replace P of A intersection B in the first formula with the P of B by A into P of A. After replacing, we get the given formula reflected on this example of base formula. Here the pictorial representation of randomized algorithm. Here the brown, the pink color represent not possible happened, the B already happened. The dark color is represented the new sample sample space after B happen. Classification of randomized algorithms are into two categories, Las Vegas and Monte Carlo. Here I am going to explain about Las Vegas. The algorithm always produces a correct or optimum result. The time complexity of this algorithm is based on the random value, and the time complexity is evaluated at the expected value. For example, randomized quicksort always sort an input array, and expected worst case time complexity of quicksort is 0 n log n. Monte Carlo randomized algorithm is produce correct and or optimum result with some probability. These algorithms have determinist running time, and it is generally easy to find out the worst case time complexity. For example, this implementation of Cargo's algorithm produces a minimum cut with probability greater than or equal to 1 by n2, and the worst case time complexity as 0 of e. Another example is Fermat method of probability testing. The Fermat method of probability testing is not important for here. The Monte Carlo and Las Vegas is the main focus area of and also the two classification of randomized algorithm. The Las Vegas algorithm for this task is keep to pick random element until we find of a1. A Monte Carlo algorithm for the same to keep picking a random element until we either find 1 or we have tried to maximum allowed time to say k. The Las Vegas algorithm always find an index of 1, but the time complexity is determined as the expected value. The expected number of the trial before success is told. Therefore, the expected time complexity is 0 of 1. The Monte Carlo algorithm finds a 1 with the probability 1 minus 1 by 2 of k. The time complexity of Monte Carlo is 0 of k, which is deterministic. There are some applications and scope for randomized algorithm. Here I am going to first condition. Say, consider a tool with a basic sorting. Let the tool be used to many users, and there are few users who always use the tool for already sorted array. If the tool used is simple, not randomized, quicksort, then those few users are always going to face a worst case situation. On the other hand, if the tool used randomized quicksort, then there is no user that always get worst case. Everybody get expected 0 and log n time. Randomized algorithm are huge application in cryptography. Load balancing is another example. Number theoretic application is one of an example that used to primitive testing. Data structure. Data structures are used to hashing, sorting, searching, other statics and computation geometry. Into algebraic identities, polynomial and matrix identity verification, interaction proof system. In the mathematical program, fast algorithm of linear program, rounding linear program, solution of integral program solution, etc. Graph algorithms. In the graph algorithm, minimum spanning tree, short path tree, minimum cut tree, etc. Counting and enumerates. Matrix permanent counting combination structures are used in counting and enumerator, one of the application. Parallel and distribution computing, deadlock avoiding, distribution concept. These are some of the examples of applications of randomized algorithm. There are few examples are there. I put on my PPT. You can read and understand. There will be a pictorial representation of randomized algorithm. The input is entered to an algorithm, and an algorithm produces an output. That is determines algorithm structure. In randomized algorithm structure, the input enters the algorithm. The random input is also input into the algorithm. That after the output is produced. In common practice, randomized algorithms are approximately used to pseudonate number, generate a place of true source of randomity. Such a implementation may deviate from the expected theoretical behavior and mathematical guarantee, which may depend on the existence of idea to random number generators. Thank you friends. Also thank you for cooperating with me. Thank you.